as the universe was first forming. Scientists believe it was comprised of more than just the regular matter that now makes up everything around us. They believe it had an almost equal amount of antimatter, matter's elusive evil twin.
If you go back to the very early universe, it turns out that it was made of matter and antimatter. It turns out that every particle has an antiparticle. And it sounds kind of crazy, but it's real. It's sort of sci-fi, antimatter.
But what is this mysterious antimatter, and where did all of it go?
Antimatter is exactly like matter. The difference between it is the fact that it has completely different charge associated with it.
Regular matter is made of atoms, which in turn are made of subatomic particles, like negatively charged electrons and positively charged protons. Antimatter are the opposite of these particles. They have the same mass, but the opposite electrical charge.
Proton's a positively charged particle, that's the nucleus of the atom. The anti-proton would be a negatively charged proton that has exactly the same mass.
In our universe, opposites attract, and particles and antiparticles are pulled together. One would think this is a relationship made for the heavens. But every time matter comes in contact with antimatter, the outcome is the same. They annihilate each other. Imagine two spaceships hurtling through space on a collision course. One is made of regular matter. The other is an antimatter craft, built by an alien civilization.
Indeed.
The impact would be spectacular, and there would be no wreckage left behind for cosmic crash investigators to examine. Volatile as antimatter is when it meets matter, there's a tremendous energy potential if we knew how to harness it. The biggest mystery surrounding antimatter is this. If there were nearly equal amounts of matter and antimatter in the early universe, then where is all the antimatter now?
One of the great mysteries of the universe is what happened to our evil twin, antimatter. Everywhere we look in the heavens, we see ordinary matter. We don't see antimatter. There's only a small amount of antimatter coming out of the center of the Milky Way galaxy.
Why this universe appears to be made entirely of matter and there isn't much antimatter to be seen out there is a mystery. I don't think it'll ever be explained anyway, but the mind hunts for an explanation.
One possibility is that perhaps there was a slightly higher percentage of matter than antimatter in the early universe. So as the particles and antiparticles collided in a war of annihilation, that small percentage of matter survived. The last living veterans of our most ancient battlefield.
And the leftover is us. We are the residue. We are the leftover of this titanic blast of energy released by the collision of matter and antimatter at the instant of time. Our most advanced theories cannot explain why there was this asymmetry between matter and antimatter. But thank God it exists. Otherwise, we wouldn't be here.
But even though matter prevailed to make up everything we see around us, could there be distant galaxies or regions of space where antimatter still reigns supreme?
it may be that there are entire galaxies that are just 99.9% antimatter, just like this one is matter. And if an antimatter galaxy were to run into a matter galaxy, then they both would be annihilated in some stupendous flash of light and power.
As strange as it is, scientists have learned how to create minute quantities of antimatter in laboratory accelerators for medical purposes. Particles of antimatter from decaying radioactive material are injected into the body to create PET scans of the brain.
Many people don't realize that when they go to the hospital and have a PET scan, they're actually being injected with a source of antimatter. The P in PET corresponds to positrons. Positrons are anti-electrons.
And it goes to some part of the body that they're trying to figure out what's going on, and then when the positron's emitted, finds an electron very quickly, annihilates with it, and the gamma rays come out of the body and are detected.
It concentrates in the parts of the brain where there's mental activity, and then we can detect the emission of positron radiation. So this allows brain scans to give us gorgeous photographs of the thinking brain, made possible by antimatter.
While antimatter has helped to unlock the secrets of the human brain has yet to unlock all the secrets of antimatter. Like many mysteries in our ever-changing universe, the truth about antimatter may remain for now in the realm of the unexplained. Mars and mystery have always gone hand in hand. But the most intriguing mystery of the Red Planet has nothing to do with alien invaders. Scientific evidence suggests that Mars was once a more Earth-like planet, with one of the key elements to support life: water.
Water existed in abundance on Mars. We find the evidence of old flows. We see a little tiny bit of water vapor in the atmosphere.
There are even features on Mars that look like old river valleys and floodplains.
It was once a tropical planet with oceans and seas, but all that water disappeared.
How could all the water on Mars have simply vanished? And why did it disappear? These are mysteries that scientists are struggling to solve. Geologic evidence gathered by the Mars rovers and orbiters suggests that 3.5 billion years ago, Mars' watery surface changed dramatically. The once temperate planet became a cold, dry place, and the water vanished. But figuring out when the water disappeared doesn't tell you where it went or why.
The water on Mars was lost a very, very, very long time ago. And I'm talking billions of years. And the clues that would lead you to know where that water went are long gone.
A series of events on Mars appears to have drastically changed the watery landscape. Mars endured an intense period of volcanism that spewed lava across the surface. When it finally ended, the planet's molten iron core solidified. This may have been what caused Mars to lose its magnetic field and protective ozone layer.
This left the atmosphere vulnerable to the solar wind from our sun, which is quite powerful.
Solar winds pummeled the planet for millions of years, stripping any remaining atmosphere. Now, water vapor that once fell as snow or rain escaped the planet's small gravitational field.
The water is brought up into the atmosphere as water vapor, and it's bombarded by ultraviolet radiation, which can split water, which is H2O, into hydrogen and oxygen. And the hydrogen, being the lightest gas known, floats up to the top of the atmosphere and can get swept away by the solar winds.
Another theory for the loss of Mars' water involves a threat from outside the planet. There's evidence that in the early years of the solar system, Mars resided in a deadly flight path.
There's one cluster about 3.9 billion years ago called the Great Bombardment that really must have peppered that planet with many, many impacts. And that kind of an event would have actually thrown material and atmosphere right off of the planet and outside of the gravitational field. Let's imagine that we have an asteroid here, and this asteroid is really the size of a mountain, and imagine this is tumbling through space at very high speed, and we're talking tens of thousands of miles per hour. If we come zipping in at high speed, splat. It's lost to space. Much of it will sink in. Some will become atmospheric gases sputtered away to space. Some will be lost.
Other answers to the mystery of Mars' disappearing water may be hidden deep inside the red planet. Some of the water combined with carbon dioxide to form polar ice caps up to 2 miles deep and a permafrost that covers much of the surface. But there's evidence that beneath the ice, liquid water still flows.
Much of the water on Mars has gone underground, and some of it certainly has migrated down to a depth where it's warm enough for it to exist as liquid water. And then when it gets colder, it's going to be frozen into a cryosphere, if you like, an ice part of the subsurface. Then near the surface is going to dry out as the water can move through the soil and go into the atmosphere.
University of Arizona scientist Peter Smith is eager to solve the mystery of Mars' disappearing water.
What happened to that water? Could have frozen into underground ice or even aquifers of liquid water. These are something we're looking for today, using radio and radar to penetrate through the surface and try and locate these reservoirs of water.
Smith believes that Arizona's Wilcox Playa reflects what scientists will find when Phoenix finally scratches the red Martian surface.
Even though the surface is parched and salty and dry, just within 6 inches of the surface is a very wet clay, like a reservoir of water, and there's a whole ecosystem of life that's living in these wet soils and these clays. When it rains, it comes to the surface. And in fact, you see little pools where actually brine shrimp that are locked into these soils. We wonder if we get down under the surface in the right place on Mars, and that is the permafrost region. Can we find the same sort of ecosystem around the ice, melting over time as climate changes, that's habitable for some sort of Martian life forms?
Some believe that life on Earth originated on Mars and that its strange transformation foretells our destiny. If that's true, finding Mars water may lead us back to our cosmic beginnings and into the future. When it comes to the universe, what we know is surpassed only by what we have yet to learn. And of all the unexplained mysteries, one remains the greatest of all. Did anything come before the Big Bang? Or was that event truly the beginning of everything? And if it was, what was the spark that lit it?
This is the greatest mystery in all of science. What started creation itself? Big Bang Theory has this tremendous hole in it. We are clueless. We are clueless as to what set the Big Bang into motion.
The Big Bang is the cosmological model for the birth of our universe, 13.7 billion years ago. Everything in our universe can be traced back to that moment.
There seems to be this mysterious point at the beginning, and we call that the singularity. But even though it's mysterious and has many open questions associated with it, it still makes a good starting point for a timeline.
But our scientific instruments are blind and deaf to the period before the Big Bang, if such a period existed at all. The singularity is like a horizon that we can never see beyond.
Because in the creation, time was created along with space and along with matter. And the Big Bang is just that sort of event. And therefore, it's impossible to know what happened before the creation event.
Nevertheless, scientific speculation as to what happened before the Big Bang is something that intrigues the greatest minds in astrophysics. Some theorists believe that our universe experiences Big Bangs at regular intervals. This cyclic model proposes that every trillion years there's a Big Bang, after which the universe expands before again collapsing, setting the stage for another Big Bang.
There's interesting ways that can connect with the story of a previous universe. The end of one universe can bring the beginning of another.
Maybe there never was a start, that it's somehow been ongoing from an earlier moment and never had a creator in it at all.
But we might be closer to an explanation of the pre-Big Bang than we know. The cosmic reverberations from the Big Bang that still echo through the universe may actually hold the answer to the moment before the singularity.
Turns out these standing waves are key to how we understand the universe today. Inflation gives the universe one big hit at the beginning, just like I'm hitting the pod right here. It forms the standing waves, and we can look for those symmetrical patterns in the cosmic radiation today. So we send our satellites out, and we observe the radiation, the symmetrical standing waves.
A new wave of detectors, gravity wave detectors, will be launched into outer space in the next decade. Connected by laser beams, any shock wave from the instant of creation will jiggle these laser beams and will be able to then record the vibrations left over from the Big Bang itself. That's why I'm confident that we'll be able to probe not just the Big Bang itself, but even the pre-Big Bang era in the coming decades.
The lasers will also detect sources of inflationary energy and perhaps determine the mechanism that created the Big Bang. If we struggle to solve the greatest mystery of all, how can we ever hope to really understand the universe?
We are the result of the universe attempting to understand itself. That's my conception. of our place in the universe. And so that makes it difficult to understand, but nevertheless, it might be possible.
The universe is constantly changing, but the laws of physics are immutable. They don't change. And that gives us hope that out of all this chaos, we'll be able to explain how it all got here to begin with.
In our ever-changing universe, the unexplained mysteries will continue to elude us. But we're edging ever closer to unlocking the ultimate secrets, the keys to our past and the pathways to our future. While science has made sense of many things, there is still plenty left to be discovered about our vast, dark, and mysterious universe.